Okay, we continue on selection of sample preparation methods when you have either inorganic or organic analytes. Okay, since that organic analytes doesn't withstand high temperature and high temperature, the sample preparation, okay, will not involve high temperature and will not involve harsh chemicals. Okay, therefore in the sample preparation for organic analytes, okay, usually will consist the word of extraction, whereby we extract out the analyte from the sample. For example, we have CHO over here. We extract out the CHO using room temperature setting and also weak acid or weak base. That's all. Okay, because we don't want to destroy the CHO. Okay, we only want to separate the CHO out of the sample. Okay, in this case, sample can be biological matrices. Biological matrices is organic sample. Organic sample means that if let's say blood contain hydrocarbon, for example, okay, hydrocarbon or alcohol. Okay, blood is organic. Hydrocarbon or alcohol is also organic. So this is what we call as organic analyte inside organic blood. Okay, what if you have inorganic sample, for example, rock? Okay, you want to analyze how much of hydrocarbon lah, for example, hydrocarbon inside it. So a hydrocarbon is organic analyte, rock is inorganic analyte. So which one to use, this one or this one? Still it is this one, because you are dealing with organic analyte. Hydrocarbon is still organic. Okay, so after you do extraction, you go filtration and reconstitute into microliter volume, because usually instrument for organic analyte require only microliter. So here you get a very good pre-concentration part. So later we will go one by one on this method. This is on the summary. Then you run the chromatography. Then what if you have inorganic analytes? Okay, inorganic analytes, because it can withstand high temperature and can withstand harsh condition and high pressure, then you have to use a very high temperature or very high pressurized condition to digest out. The key word is digest. You want to digest out the inorganic analyte out of the organic sample. So it will involve a lot of the word digestion, open wet digestion, microwave wet digestion, and so on. Etching is also one of it. Okay, so this is in the case if let's say your sample is still blood, kan, blood is organic, right? Okay, it contain heavy metals such as mercury. So which one to use? You can use digestion. Why? Digestion can destroy blood, leaving out means digest out the mercury. And then another one, you have rock. Okay, rock is inorganic, right? Inorganic sample. And then still you have mercury inside that rock. So inorganic analyte inside inorganic sample. So you have to use etching, because only etching can destroy the rock. So it is always like that. Okay, so after you understand this, you can understand most of the examples. After you do digestion, you filter and further dilute and run for spectroscopy based analysis. You see here, inorganic analyte go into spectroscopy, organic analyte go into chromatography. In Dr. Afi's class, you can ask what is the difference between them. Okay, they are dedicated instrument for each of them. Okay, let's go back to sampling. Sampling is you want to get a representative. Still remember, a representative, and most of the time you want homogeneous sample. But sometimes you cannot get homogeneous sample. For example, the oil and water sample yang Gulf of Mexico just now, oil and water. Therefore this is heterogeneous, but you can get homogeneous after you do some pretreatment, whereby you eliminate the water by boiling or by distillation and so on. Okay, you want to sample to the size that is suitable for you to bring back to lab, and also you want to see what is the chemistry of the material, and also what is the physical state. Is it solid, liquid, gas? We will go into we will go into solid type later. Okay, when you want to do sampling, you have to identify, do I want to get grab sample or sampling something like gross. So you want to get grab sample whereby in like for example seawater in a 10 radius, 10 kilometer radius, you want to get 10 part where you want to sample, so it represent the whole 10 kilometer kilometer radius over here. So that's what we call as grab. When you grab it, you pull everything inside one container. If let's say you take 10 mil, 10 mil, 10 mil until so on, and then you will get 100 mil here because you have 10 location. Okay, so 10 mil times 10 location, you will get 100 mil. So this is the representation of the whole 10 kilometer radius. Who decide 10? You have to go back to the ASTM, APHA, or AOAC. They will tell you which one is the standard one. Okay, so this is easier when you want to defend your data in court, whereby you will be asked by, for example, lawyer or judge, how do you sample? Okay, you said I follow ASTM method on collecting water at 10 points. This has been validated and used around the world and is also verified. That's it. That's the answer. Okay, always stick to the standard method or published method on sampling, and it goes towards anything, sample preparation as well. Okay, so this is the example just now I mentioned. Okay, after you grab, you combine to get a composite sample, and you can also do in situ sampling, usually for gas sample. So for gas sample, we will go later, okay, when we go into gas type of material. This is the one that I mentioned just now, APHA, AOAC, and it must be homogeneous. If you cannot get heterogeneous, you have to think of how to make it homogeneous. Okay, this is how to sample solid. Okay, because solid is not homogeneous, sometimes it is different size, right? Sampling of solid is more difficult. It is more difficult as compared to liquid sample. Okay, the easiest way is to grab. This is like literally grabbing the powder, okay, at different timing, if it's on conveyor belt, or different location. Location is the best lah if it's stationary. For reliable result, you can take 1/50 or 1/100. Sometimes it says 1/10. The higher the portion, the better, because you like take more representation of the whole area or bulk. Okay, so this the example for here on how you want to take sampling of grains in a warehouse. So you go into different part of warehouse area, you take one siphon out of this, and then you go in back here, get and so on. So this is like bulk. But what if you have a conveyor belt? So this is even better because it is time based. Means that, okay, you sample at 30 minutes time interval. It's even easier. Okay, what if you have something like metal and alloy at different places? You can drill. Okay, drill. Okay, so this is the conveyor that I mentioned, usually for grains. Okay, you want to quality check it. Okay, so after you get the sample, okay, you get the bulk sample, and then you combine it. Still it is different in terms of size, right? So how do you want to make it homogeneous? Easy. You can grind, or the easiest one is, if it's in the lab, you can blend using blender. Okay, after you blend it, you filter it or you sieve it so that you can get same size. Okay, so this is the blender that I mentioned, usually useful for animal tissue, food and environmental sample, and finely divided particle will promote more efficient extraction. Okay, so this is the example of how my PhD student prepare his muscle sample, whereby muscle sample is organic, kan, organic sample containing heavy metal apa? Heavy metal inorganic. So he want to destroy the organic matrices, the sample, and leaving behind heavy metal for analysis. Okay. So this is where he actually like grind together with the spatula before he blender it inside the normal kitchen blender. Okay, so after he blended, you get a very murky solution. So for easier storage, you can dry the sample. Dry the sample as easy as put it inside desiccator or oven, but it is depending on your analyte. If it's if your analyte is inorganic, it's okay because it can withstand temperature, right? So heating at 110 degrees C to remove H2O is okay. But what if you have biological sample? You can only dry in vacuum desiccator under nitrogen, okay? Because it will retain the biological the organic biological aspect of it. Okay, I put over here several questions for you to think of. Okay, try and answer it, and you can also put inside WhatsApp group for us to discuss.
This procedure is applicable.
So this is the video of doing coning and quartering. So watch the video first, and then after this I will explain in next video.
Pile the sample in a cone shape by placing each scoopful or pouring each bucketful at the center of the cone so that the perlite will disperse equally in all directions.
This is perlite sample. So this is inorganic sample containing inorganic analyte. You see that the size of the perlite sample reduce every time he do the cone and quartering. See, remove. So this is to make sure homogeneity, to make sure the fairness in terms of sampling. So this is accepted worldwide.
Do that by taking alternate scoops or shovel loads from the 2 quarters saved, or combine remaining quarters into a bucket and make another conical pile. Continue this process of piling, flattening, and rejecting 2 quarters until the sample is reduced to the approximate required testing size.
So now it's becoming smaller and smaller, okay?